Hello, it's Dr. Daystorms, and this lecture is going to be going over the different methods of how to make measurements in your crime scene sketching. We're going to be focusing on the rough crime scene sketch because that must include all of your necessary measurements. Remember, the only difference between the rough crime scene sketch and the finalized one is that the finalized crime scene sketch is drawn to scale. So let's go ahead and get started. There are four methods that you need to know: the rectangular method, triangulation method, baseline, and polar coordinate methods. With each of these, you need to know how many fixed points of references are required, how each is going to be used, and you need to be able to use each method in creating a rough sketch. And we'll go over examples of this because I know the figure in your book can be a little confusing at times, at least it was for me. And then give examples when each method is useful. This first method is the rectangular method. And what you're going to need, what's so important here, is that you have to have two fixed flat surfaces. Many times what we're talking about are walls. So for example, walls of a room can be two fixed flat surfaces. All you need to do is make 90-degree angles between your surface and whatever object it is that you're trying to measure, your piece, your evidence. The instance in this example from your book is like a barrel or something. So first off, you're going to measure the distance between your object and one wall, and this has to be at a 90-degree angle. Okay? In this instance, it's 15 feet. And then likewise, we're going to measure from that same object to the different wall at a 90-degree angle. And once again, this instance it's 7.75 feet. Now, one word of advice that I have for you is that in order to get orientation, you should do for example, of a body. If it's a small object like this right here, then it doesn't really matter. But let's say it's a body or something that's larger, you'll probably want to do 2 points of reference. Okay, let's look at an example of using the rectangular method. So let's look at a specific example using the rectangular method. I'm going to measure this evidence number 2 as denoted in this crime scene sketch right here. Please don't worry, I wouldn't expect you to have a finalized crime scene sketch this neat. But evidence number 2 was this large pool of blood. So first off, we have to have two fixed flat surfaces. So one surface that we're going to use is, let's use this wall. And for the second surface, I'm going to use this wall. Okay. And one thing I just wanted to point out, in case you didn't know, this little figure here just shows that's how the door open and closing. So it's an entrance or an exit. So first up, we would measure the distance from at a 90-degree angle from the pool of blood to that wall, and then for the second frame of reference, 90-degree angle, we measure that distance. So, and I'm just going to give an example here. So for example, this could very well be 15 feet, whereas from here to the first wall, perhaps it's only 6 feet. Okay, that's one way of using the rectangular method in doing your crime scene sketch. The second method we're going to be talking about is the triangulation method. It's a little bit more complicated, in the sense that you have to use something to measure an angle. So it's something like a protractor or another instrument to measure an angle. And it requires only two fixed points of references. So you don't actually have to have a flat surface at all in this instance. You just have to have two immovable objects, essentially. Now, because of that, since you have two objects, which in this example here, they're showing it as point 1 and point B, for whatever reason they used a 1 and a B, but those could just be, say for example, two light poles outside. It doesn't really matter. You do not necessarily have to have a wall. And then we have our object that we want to measure over here. And all you do is, it's not as difficult as what you may think, is you just simply measure the distance between each of these points. So for example, we measure the distance there between our object, which they say 0.3, and point B. And so I'm going to call that X. And we would measure the distance between our object and point A, and that would be called position Y. And then finally, we just have to look and measure this angle and write down the angle that's made between point 1 and the distance that I have as Y, and measure the angle that's made between point B and its distance. So let's look at a specific example once again, like we did in the previous time with the rectangular method. So in this example here, I'm going to use the triangulation method to measure the location of the victim's knee with respect to two fixed objects. And what we're going to do is use the doorway, the door frame here. So I'm going to have point A and point B, so to speak. Those are my two immovable objects. And all that we have to do now is we're going to measure the distance between point A and the knee, so called X. Okay. Now let me undo it so that way it doesn't get too cluttered. And I'm going to measure the distance between, let me change colors, the knee and this, and I'm just going to call it Y. So we have two distances, but now we've got to do the angle. And so you can imagine here's a baseline between those two. The way that you do the angle is you use your protractor to measure that angle that's formed between, in whatever that color is, that the angle that's formed between that baseline and your measurement, and you do the same thing here between the baseline and the measurement to your knee in this instance. And please note, it should be less than 90 degrees. If it's over the 90 degrees, then you're looking, if you're using a protractor, you're just looking at the wrong set of numbers. The third method that we're going to be using today is called the baseline method. First off, I want to say that this is really useful for large crime scenes, large open crime scenes, or a large room perhaps. It's also useful in outdoor settings. The only thing it requires are two fixed points. So once again, it could be like two light poles outside or anything like that. And essentially, you're going to be creating that baseline like we did in the triangulation method, but here we don't have to worry about any angles except for 90 degrees. This reminds me of back when I was in elementary school and you had to draw out the number lines. You know, we'd have like a 0 and 1 and 2, 3, so on and so forth. That's essentially what you're doing here for the baseline method. Okay? So, let me erase this all. What you do in this instance, this was one of the most difficult figures I thought to read or to figure out what was going on in your book. What we're going to do here, let me change colors so we can see it better, is this would be, for example, one light pole or in the second light pole. Then we have a baseline that connects the two. You know, it's an imaginary line. What happens here now is that for each of these, let me change colors. What they're saying is from the distance from here to here is 6 feet, 7 feet, 8 feet, 9, 10, 11, and 12 feet. This is the object that you're wanting to measure and to look at. What you do is you go from that object to the place on the number line or the baseline where it hits and makes that 90-degree angle. Okay, you measure this distance. This distance here is 6.5 feet. Then you measure the distance along the number line. Oops, let me change colors. Along that number line. And lo and behold, it hits that number line or the baseline at 10.75 feet. So let's look at an example, specific example like what we've been doing for the other methods. Okay, first of all, don't judge my drawing abilities. But in this instance, we're outdoors. You found a body, and we have two fixed immovable objects. We have a tree, and we have a statue. My version of a statue. Just something that's just not going to be able to be moved. Those are what we're going to use for our fixed points of reference. So now we can imagine that we have a number line or a baseline that runs, that runs from the base of the statue to the tree. Okay? Now, what we are going to do is we just have to measure, and we're going to call this point down here 0. This point down here 0 feet, and then you would measure the distance away. And let's say that the tree, for example, is 50 feet away. This is not drawn to scale. Okay. The way that this works is we're going to measure from the top of the person's head to the baseline or the number line. So where does it hit along this number line? So you would actually then just have to measure from the statue to this location on the line. And so in the lab, what we would do, since we would stretch yarn or a string, or they could even use a laser pointer to do a line that goes straight across from one object to the other object. Then you just measure where it hits that line there. So in the lab, this would be a piece of yarn, but you just measure that distance. And so we would say, for example, that distance is 37.5 feet. That's just an example. Likewise, we now have to also measure the distance that we are from the number line. So for example here, maybe this is 10 feet. So that's how you use the baseline method, is you create a baseline between two fixed points of objects. You do not need a wall, and you just measure where it falls, measure 90 degrees to where it falls on that number line. In this instance, it's 37.5, and the distance it is from that number line, that baseline. So here it's 10 feet. Now, just as a practical standpoint, if you're doing this for real, you'd want to do as many points of along the number line as possible. So what I mean by that is we would also want to, in order to get the orientation, we would, for example, want to measure like how far away, do another one for the foot, maybe another one for the hand, and so on and so forth. The more points of references that you have, the better your sketch would be. Our final example is the polar coordinate method. This one typically is the one that's the most difficult for students to grasp. However, once you know how to use it, it's actually fairly simple. One nice thing about it is that it only requires a single fixed reference point. All you need to do is you measure the distance of the object to the reference point, and then you measure the angle it's created between the object and that fixed reference point. It does require a protractor or some type of instrument to make a measurement, similar to the way that we have seen with the triangulation. Okay, so let's just do an example. Oh, an example that came from your book is we have our barrel. We have only one point of reference here. It's A, you measure the distance from A, and then you measure the angle that's formed whenever you do that, which is 60 degrees. But let's look at an example on our own. Okay, so in this instance, perhaps you found the victim. The victim is located outside, and the only thing around is just a fence, right? So we only have one point of reference here, per se, and so all we have to do is we can make a measurement using one fixed point. So I'm going to use this end of the fence as my fixed point. The way that this works is I just measure. I'm going to measure to the victim's foot, the victim's right foot. I make that measurement, and it's, for example, maybe it's 15 feet. Okay? Then the second thing that I'm going to do is I just use a protractor or another instrument to measure the angle that's formed between my point and that measurement. So, for example, maybe this is 45 degrees. And that's it. It just takes that one point and that one angle. Now, if you're doing this for real, what you'd want to do, once again, in order to get orientation, is you would want to do an additional one, or as many as possible. Let's say, for example, maybe we want to measure from the victim's arm to the angle. And so perhaps that was 18 feet. And then we have a new angle here, and that's 50 degrees. And you just repeat this for as many points of reference as you need. The more points of reference, or the more measurements, I should say, that you have, the better your results would be and the better your sketch would be. So if we'd like to do another example here back in this carnitine sketch, what we could do is, an example here that we could do is, let's measure from the victim's head. This would be my point of reference. So that's my fixed point. All I would do is I would measure the distance. So I'm just going to call it x this time. And then we can imagine that I just have to measure the angle that's formed by this. And so I'm going to do it, doesn't really matter, I'm going to do it, the angle, this angle here, and for example, maybe it's 135 degrees. And that would be using the polar coordinate method. Hopefully this has helped give you a feel for the 4 different types of methods that's used in how to record your measurements in a crime scene.